Introduce yourself to the audience and tell them about your capabilities. Hello everyone, I am the AI Roundtable Advanced Multimodal Chatbot. I'm here to assist you and answer your questions. I have a wide range of capabilities to help you out. I can act as an AI assistant similar to ChatGPT. I have full RAG capabilities, which means I can answer questions based on pre-processed documents, uploaded documents, and even provide information about the contents of a website based on your query. I can generate images using the Stable Diffusion model. I understand the content of images using the LLAVA model, so if you have any image-related questions or need analysis, feel free to ask. I have access to the DuckDuckGo search engine, so if I don't have the answer, I can search the web and provide you with relevant information. I can summarize websites or documents if you ask me to. You can interact with me through text, voice, and even images. So first of all, I hope you had a great day, and as I discussed in my previous videos, at some point I wanted to design a multimodal chatbot. So here we are with version 1 of multimodal chatbot. So before jumping on the projects and going through all the details step by step, let's first go through some of the features that we just saw and see how they work. As we saw in the description, one of the models that is active behind the scene is LLAVA, and LLAVA is a model that has two different capabilities. The first one is that it can act with text, so you can use it just like ChatGPT, but also it can understand images. So let me give you an example. Here I have an image of a flat tire. If I pass this image to my model and ask, this is the image of my car, what should I do? The image shows a car with a flat tire. Here are the steps you should take. And it goes through all the steps and give you all the details for changing that tire up to get the flat tire repaired or replaced. So this is the amazing thing about this model, and I will go through all the details when I'm talking about the models behind the scene. So if you have watched the channel, you know that I have two different models that I've already covered in detail. One of them is called RAG-GPT and the other one is called WebRAGQuery. So this chatbot has all the capabilities of those two models. So you have access to a full RAG chatbot, so you can chat with your pre-processed documents, you can upload the documents and start chatting with it, and you can also ask the chatbot to summarize the document. You can upload the document and ask for summarization. So on the WebRAGQuery side, a GPT model is going to get connected to the DuckDuckGo search engine, and when you start asking the question from the GPT model, it can answer your question based on its own knowledge, but as soon as you ask something which requires some, let's say, web search, it's going to search the web for you and give you the answer based on the results of the web search. And on the other side, you can also ask the model to set up a RAG pipeline for any website that you have in mind, and then you can start asking questions from the website. And finally, you can also ask for image generation from the chatbot. But for now, let me test the RAG side of it. So one of the documents that I have prepared already is the paper for the vision transformer model. If I ask, what is VIT? VIT stands for Vision Transformer. According to the retrieved content, VIT is a model that performs well in computer vision tasks. So this is the right answer based on the retrieved content, and we just saw the RAG side of the project with the pre-processed documents. I will skip these two aspects because I will go into much more detail when I'm talking about the project, but I want to show you one of the WebRAGQuery features. So if I activate WebRAGQuery and if I ask, I'm looking for videos that teach me how to cook Italian pizza. Here are some videos that can teach you how to cook Italian pizza. So let's open one of the videos together. So as you can see, this is a video about how to cook pizza, and this video was uploaded 8 days ago on YouTube. So this is a very recent video. Let's open another one here. Again, crafting perfect pizza, and it also has unleashing the Italian flavors, and this video was uploaded on YouTube 3 days ago. So this is how the model is able to use a search engine and give us an answer based on the search results, which might look like this. You can also search for news. You can search for a bunch of stuff. Also PDF files. You can even add more functions if you want to get more functionalities from this model. And now let's go to the stable diffusion side and let's see how we can generate an image. So let me ask, generate an image of a happy boy in the swimming pool. Okay, so my voice was not detected properly. Let me ask it again. Generate an image of a happy boy in the swimming pool. Hopefully this one, it is going to get it correctly. Here we go. So this is the image of a happy boy in the swimming pool. And if I open the image, you are going to see the full size image. So this is nice. This is something that we also have with this chatbot, and all these models except the GPT model is open source. So you have a ton of options out there. You can modify the models, use bigger models based on your GPU. I just need to mention also that the chatbot itself, it is not connected to this microphone that I'm using right here. As a matter of fact, it is connected to my headphone because I realized when I'm connecting it to the same microphone when I'm recording the video, it automatically increases the gain, which is something that I didn't want. So the fact that it couldn't get my first query properly is because I have a little bit of distance with my headphone, which is sitting on the table right now. Okay, so now let me go through some of the key aspects of the project. To run this project, you need something around 14 gigabytes, definitely less than 15 gigabytes of GPU VRAM. And if you are willing to do the refactoring, you can actually run the chatbot on a T4 GPU on Google Colab. And although we are using 4 different models behind the scene, you need only one Python environment to run the whole project. You don't need to download any model weights, and every single model is being called directly from the Hugging Face hub, and this is going to make things much easier for you. It requires a Linux operating system, or in case you use Windows just like me, you need to have WSL installed on your Windows, and you need to use WSL. And the reason behind that is with the LLAVA model, I'm loading the quantized version of the model, and for that I'm using bits and byte library, and that library is not yet supported on Windows, so we don't have an option except running it on a Linux operating system. For this chatbot, you need to update 2 of your libraries, which are Gradio and Transformer libraries, and you need the most recent version. As I said, the LLAVA model that I'm using was released last week, and for that we need the most recent version of Transformer model. So the way that I'm going to go through the video is, first I showed you a quick demo of the chatbot, and we just had an intro together. From here, I want to walk through the GitHub repository and show you the repository, and then I want to quickly show you the models and the documentation of each model, and then I will show you the project schema, and we will go through the project as we have done so far in the previous videos. So let me quickly go through the project repository. So again, the repository is the same LLM0200 repository, and I have added the project already. So if we go into the advanced multimodal chatbot, you can see the features of the chatbot, and you can see the techniques that are being used for designing this chatbot and the models that I used for designing this chatbot. So first of all, I'm using GPT 3.5 and text embedding auto, which are OpenAI models. And also I'm using LLAVA and Stable Diffusion and Whisper, again from OpenAI. But these models are all open source. Now let's quickly go through the documentation and see the models that we are using for this chatbot. So this is the OpenAI models that you can use. From these models, I'm using GPT 3.5 Turbo, and in the embedding models, I'm using text embedding ADA 002. They have also recently released 2 new embedding models, which I'm not using at this point, but I guess actually if you use text embedding 3 small, it should be the equivalence of the text embedding ADA, and if I remember correctly, it should be a cheaper model. So just keep it in mind that actually it might be a better option for you to switch. But since I used this model in the previous project, I kept it for this one as well. Then we have the LLAVA model. You have access to the repository. So in case you are interested in fine-tuning that model or doing anything besides just loading it and using it in your chatbot, this is the repository that you can go and you can do a bunch of stuff with this model here. This is a fantastic project. They also provided us with a demo. As you can see here, you can start interacting with the model. They gave us access to their biggest model, which is 34 billion parameters, and you can see how it works. Here you can see the performance of LLAVA compared to other baselines, and here you can see their different models. So they have LLAVA with Vicuña and with Mistral 7 billion, and for this project I'm using this one, LLAVA with Mistral 7 billion. And for the stable diffusion, I'm using this model from Hugging Face, and for speech to text, I'm using OpenAI Whisper-based model. So these are the models that I'm using behind the scene for the chatbot, and I've also provided you with all the necessary links if you want in the repository, and I also gave you the description on how you can run the project. It is very easy to run the project, especially if you have already watched my previous videos, because first of all, the structure of the project that I'm using is the exact same structure that I've used in the previous ones. And also the way that you can create an environment, install all the libraries, and then start executing the modules is exactly similar to what we have done so far. The only thing with this project is, to make it easier to run the project, I added a bash file here, which, as you can see, executes 5 different terminals, runs all the models, and also initializes the user interface for you. So you don't need to do it manually. And again, just like the previous projects, since this is a big project with a bunch of modules, I'm not able to start writing the code for you in the video. But what I do is I go through the project schema and I will explain to you each branch step by step. So this is the project schema of our multimodal chatbot. As you can see here on the right, we have RAG-GPT, and here we have WebRAGQuery. So those two chatbots that we developed are two arms of this multimodal chatbot. On the other side, our user can start interacting with our chatbot using text, voice. We can also upload an image, or we can upload a document. So that document is going to either go through the RAG pipeline for Q&A, or we can ask for a summary of that document. So let me quickly go through RAG-GPT and WebRAGQuery. I have 2 videos explaining these 2 projects in detail, and it is just impossible to cover everything in one video. So I strongly suggest you to watch the other 2 YouTube videos if you haven't watched them yet, because these 2 projects by themselves have a lot of details. So as you remember, on RAG-GPT, we designed a full RAG pipeline. On the right, we have the data pipeline, and I showed you how to process your documents and create the vector database from them. And we also just saw that in case the user decides to upload a document while using the user interface, it is going through the same pipeline, and a vector database can be created from it, which gives the user the ability to start asking questions on demand. On the other side, we had another feature in this chatbot, which was summarizing a whole document with one inference. So as soon as you upload a document and ask the chatbot to summarize it for you, it can go through all the pages and create a summary from that document for you. In WebRAGQuery chatbot, we had 4 different functionalities. The blue line shows that the chatbot can act as a simple AI chatbot, ChatGPT. Then on the red line, we can see that the chatbot can start searching the web automatically based on the user query. So this is where I used function calling to make this happen. So as soon as you ask a question, if the model, the GPT model behind the scene, does not have the necessary knowledge to answer your question, it is going to use one of those functions and give you the result based on the function. And all those functions are connected to DuckDuckGo search engine, and it can use the web search result to give you an answer. Then we also had the purple line, which gave us the ability to summarize a website. So you can provide a website to the chatbot and ask it for a summarization. Just like what we had here in the red line, which was with a document, we can do the same with a website. And here on the pink line, we could ask the chatbot to set up a full RAG pipeline for a specific website. So as soon as the RAG pipeline is ready, you can start asking questions about the content of the website. Again, just like what we had here with documents, we can have the same with the content of a specific website. Here on the bottom, I'm showing you a small slide from the open source RAG project that I have on YouTube. I'm just showing you this because if you have watched the video, this is the exact same strategy that I used to load and serve all our open source models. So we have LLAVA, we have OpenAI Whisper, and we have a stable diffusion model. All those three models are going to be served on a Flask web server, waiting for our query coming from the user interface. So I have already discussed why do we need this strategy or these type of strategies for loading a model on a separate web server in open source RAG project. So I'm not going to go into the details, but I will show you how I'm doing it in this project. So now let's go back to the project schema. This is our project schema. And first, let me show you how the RAG-GPT side of our project works. This is our project, the repository. And again, as I mentioned earlier, I'm using the exact same structure as before. We have the config files, but in this project, since it is a much more complex project, we can say there are 4 YAML files in our config folder. We have the data folder where I'm keeping all my data sets, including the documents, images, and vector databases. And also I have a folder called Explore. I'm keeping this folder in the repository because I received a lot of requests in the previous videos about the notebooks that I use for exploration, for personal exploration. These are the notebooks that I used personally in order to develop the chatbot. So technically, you can go through different models, you can execute them in a notebook. Then we have images, which I'm using for the chatbot UI, and we have the source folder. So first of all, you can see that I have an app.py here, which contains my user interface, along with 3 functions here that connects my user interface to all the codes in the backend. So whatever the user does with the user interface, it is going to be sent back to my backend through these 3 functions. I just kept it very simple, again, just like the previous projects, because I like this module to be very simple. And if you execute the module up to this part, and if you just comment out this section, the user interface will pop out, the skin will pop out, and you can see the Gradio user interface. But as soon as you pass these 3 functions, now your user interface is connected to the backend. So you also have prepare vector database from docs. This is the only module. So beside this bash file here, in case you want to run the chatbot with all the features, and in case you want to prepare a vector database from your documents and have RAG capabilities with those pre-processed documents, this is the module that you have to execute separately. So usually when it comes to RAG projects, I strongly suggest you to separate the data pipeline from the chatbot and the RAG side, let's say the retrieval and the inference side, because to me these are 2 separate projects. But since this is a YouTube video and that would make things just complicated, I am keeping all of them in the same project. But still, in case you want to prepare the vector database, this module needs to be executed separately. So as you can see here, to prepare the vector database from, let me also zoom in. So as you can see here, to prepare the vector database from your documents, place your files in data docs folder, run this module in the terminal. A vector database will be created from the documents in data vector database process directory. So if you put your documents here, as soon as you execute this module, you will see that in vector database folder, there will be a folder called processed, and it's going to contain your Chroma vector database. So this is, if I go into RAG-GPT, this is this black line right here. All right, now let me show you the user interface. This is our user interface, and as you can see, on top we have chatbot functionality, and if you open it, you have different tasks that the chatbot can do, and you can select your desired task. We also have LLM parameters, and here you have access to two different parameters, temperature and max output tokens. So temperature is the parameter that you can use for the GPT model, but only for the AI assistant. And the reason behind that is, if you remember, for the RAG side of the projects, I strongly recommend to use temperature equal to 0, because that just means that the model is going to perform more consistently. And we also have max output tokens, which is the number of output tokens for the LLAVA model. So keep it in mind, this is not going to be applied on the GPT model, and this is only for LLAVA. Then we also have some RAG parameters. So I just thought it would be nice to have a little bit of flexibility inside the user interface regarding the RAG side of our project. So you can define the number of retrieved content here. So by increasing K, for instance, from 2 to 3, instead of 2 chunks, your RAG pipeline is going to retrieve 3 chunks, and then it's going to pass those 3 chunks to the GPT model. You also can choose the search technique. So I provided you with 2 different search techniques, similarity search and MMR search. So these are my favorite search techniques in LangChain, and you can start playing around with them and find out which one would lead to a better result in your RAG project. Then we have the voice block along with the submit button. We have the chatbot itself, the input text, and this is a multimodal input text. So that is why I mentioned that for this project, we need the latest version of the Gradio, because this block only exists in the most recent Gradio version. Then we have the upload PDF or doc files. Then we have references, which is the markdown for showing the sources and the chunks of the RAG side of our project to the user. And then we have the clear button, which clears everything in the chatbot. So if I go through the code, we can see the exact same things that I just showed you on the user interface. On the top, we have the app functionality with all the functionalities that we just saw. We have LLM parameters, the temperature, and the max output token. We have the number of K, or the number of chunks to be retrieved in the RAG project. We have also the search type. We have the input block along with its submit button. And then we have the reference button. Actually, this is the reference bar, which is not visible initially, and it's going to be visible only if we click on the reference button. We have the chatbot output. We have the feedback, the input text, the multimodal input text, and all the buttons on the bottom of the page, the upload button, the references button, and the clear button. This is how I designed the user interface. So here are the functions that connects the user interface to the backend. So on one side, I mentioned how you can pre-process your documents and create a RAG pipeline. If you see here, you will see that this function calls out a class called prepare vector database. So let's keep it in mind, and now let's see what happens if the user uploads a document. So as soon as the user uploads a document and press on the upload button, this function is going to be executed. So let's go inside this function. It is going to automatically get the directories of the files that the user uploaded while using the user interface. It also receives the chatbot. It contains the chat history of the user and the app functionality. So as I mentioned, when you upload a document, 2 things can happen. You either are looking for a summarization of that document, so that is going to be this functionality, or you want to have a RAG pipeline ready for that document. That is going to be this functionality here. So right now, I just want to focus on this side. So if this is the functionality that you have selected. Again, you can see that I'm calling the exact same class as we had here. So if I show you the project schema of RAG-GPT, you can see if we go through the offline documents or we go through the upload documents, at some point of the pipeline, they are going to merge into the same workflow. So that is exactly it. That class is going to be shared within these two approaches. The only difference is the way that you are passing those documents to that workflow. So let's see what happens inside this class. This prepare vector database is from RAG-GPT folder inside utils. So in utils, you have the AI assistant, which is the AI assistant side of the chatbot, just like ChatGPT. We have RAG-GPT, we have web servers. These are all our models, and I will explain them later. And we have WebRAGQuery. So for now, let me just go through prepare vector database. In RAG-GPT, we have prepare vector db.py, and this is the module. So here, we are supposed to have the directory of our documents. And the directories might come from the upload documents or from the documents that we put in this folder right here. So as soon as we have the data directory, the whole process is the same. We are going to load all the documents or the documents that the user uploaded. We are going to chunk the documents. And from the chunk documents, we are going to prepare our vector database and save it on vector.db folder. So this is the exact same way that we are going to prepare the RAG pipeline for upload documents, pre-processed documents. And also when we want to set up a RAG pipeline for a specific website, this is the same workflow, but I separated them in RAG-GPT and WebRAGQuery just for simplicity. So now we have our RAG pipeline ready. So up to this point, the offline documents or upload documents are processed and a vector database was created. In the next step, the user can start asking questions. So as soon as the user starts asking questions, it is going to go through one of these two functions. And the only difference that these two have together is one of them is looking at the input text and the other one is looking at the audio submit button. And as you can see, inside these two functions, whether it is the input text or the audio submit button, I'm using the exact same function with the exact same arguments. So these are just two different directions that the user can choose to interact with the chatbot, and the rest is exactly identical. So the user can select any of these functionalities. And as soon as we ask a question, it is going through this function, which is called respond. Here in this function, which is coming into chatbot.py in utils folder, if you check this module, you will see that we have all our functionalities listed here, and each functionality is calling a separate function or a separate class to perform the task for us. We have RAG-GPT, RAG with process documents, we have GPT AI assistant, we have RAG with upload documents, GPT with DuckDuckGo search engine, RAG with websites, etc. So this is somehow the second layer of our modules that distributes the user's query, the user's message over the whole backend and gets the right response and send it back to our UI. So in app.py, I only had the user interface, and as soon as I get the user's query, I send it to chatbot.py, and this is where I'm calling out the right functionality, executing it, and getting the response. So just keep it in mind that these two layers are the top layers of our project. So now let's say that the user selected a RAG functionality. It is either RAG with process documents or RAG with upload documents. Again, if you check here, you will see that I'm calling the exact same class. So that is perform RAG class here and perform RAG class here. The only difference is the data directory. So it is pointing to custom persist directory and it is pointing to persist directory. So These two again are identical, with the only difference is that they are pointing to two different vector databases. So now let me go through this perform RAG. So this class, which contains a perform RAG function, loads the vector database, perform the search on the vector database, retrieve the content, and pass the content along with the user's query, along with the chat history, to the GPT model. This is what this class does. And if you go through different functions, you would see that we have load vector database, search the vector database. Also, I'm cleaning the references because if you remember, when we are using Gradio, when we retrieve the documents, they are not going to be shown cleanly on Gradio. So in order to show them in a nice format, I added a clean references function, which does it for us. And then we have ask GPT model. And if you check the configs folder, the RAG-GPT YAML file, you would have access to all different configs that are required for that specific branch. On the top, you can select where is your data directory, the main one that you are going to pre-process, or the one, for instance, in my case, that I'm using for upload documents. Actually, this is not necessary. This is just something that I was exploring personally, but it is right there. You have the persist directory where you want to save your vector database, which was created from the process documents, or where you want to save your vector database, which was created with the upload documents. And then we have the embedding model, which has the name of the embedding model. We have the LLM system role. So you can start changing the system role for the RAG side. I have the engine of my LLM, which is GPT 3.5 Turbo. I have the temperature, and I have the max number of tokens. So these are somehow the static configs that I'm using for the RAG side. Again, I've explained it why, and I didn't give the user the ability to change the temperature or max token because I wanted the full power of my GPT 3.5 and I wanted the most consistent performance of my GPT 3.5. So this is how our user can perform RAG with the processed or upload documents. And as soon as we run this function, RAG instance perform RAG, we are going to receive the response and the retrieved content. And we are going to pass it to the chatbot. So the chatbot is going to show the response of our GPT model and also is going to show the references along with the retrieved chunks to the user if they want to. So this is the exact same process for both cases. If I go back to the project schema, that would be this orange branch here along with our RAG-GPT. But our RAG-GPT had also one more functionality, which was summarizing a document. So in case our user here selects RAG-GPT summarize a document and uploads a document, it is going to be pointed to this function right on the top, and it is going to enter this second functionality, which is summarize a document. And if I go into this function, you will see a class called summarizer, and this class is going to take that PDF or document, go through each page, create a summary of each page, and then pass all those summaries to another GPT model for a final summary. As I mentioned in RAG-GPT project, this branch needs to be modified based on your needs. So there are two main issues with this branch. The first one is if you upload a document, let's say with 50 pages. So the way that it is implemented right now, it needs to fit all the summaries of those 50 pages into one inference for the final GPT model. So it's going to calculate the length and assign the proper length to each page automatically, which might lead to a bad summarization at the end, because let's say with a long document, it is going to push the first model to give me a summarization from this whole page, which is less than, let's say, 10 words. So in that case, that model is not going to be able to give us a good summary of each page. The second problem is the number of API calls that you want to make for a long PDF that you need to be careful about, and also you have to take into account. But on the other side, if you pass, let's say, a PDF with 10 pages, this is a perfect branch. It performs the summarization in a very nice format, and it can give you a nice summary at the end. So to answer some of those questions, one way that I would improve this class is when I get a PDF, let's say if it has 50 pages, 100 pages, doesn't matter. I would load the PDF, I would count the number of pages, and then I would divide that PDF into smaller chunks, and I would put a threshold. For example, I would say each chunk should have maximum 15 pages. And then I would start to pass those chunks to this class, get the summary of each chunk separately, and then merge all those summaries and pass it to another GPT model. That would be approach number one. The second thing is I would use a more powerful GPT model. I would probably use GPT-4, which has a longer context length, and it is much more powerful than GPT 3.5. So these are the two main changes that I personally would have done in case I wanted to use a longer document. But for my personal use case, this class works just fine. I don't want to pass documents with 50 or 100 pages, and just keep it in mind that this is what you need to do in case that is your use case. So we just saw that we are going to enter this summarizer class and go through each page, create a summary from each page. This is where I am summing up all those summaries, and I'm passing all the summaries to a final GPT model to get the response. So that is how I'm doing it here. And for now, we covered all the branches in RAG-GPT. So we saw everything on the left branch. Let's see it in action. So let's use our chatbot, and let me clear the chatbot, go through RAG-GPT. As we saw, I have a vector database ready for me. So again, if I ask what is VIT, so let me actually show you the difference between RAG-GPT and GPT. So right now, this is going to be asked from a normal GPT model that is not connected to my vector database. So with that question, GPT would come back with VIT stands for Velour Institute of Technology. That might not be a wrong answer, but that is definitely not what I'm looking for. So if I switch back to RAG-GPT, RAG with process document, and if I ask the same question, it is giving me the same answer because of the chat history, I assume. So it got a little bit confused. So let me just clear the chatbot and ask the question. VIT stands for Vision Transformer. It is a model that performs very well on recognition benchmarks. That was a good example, actually, because when we are using memory, we need to be very careful about the context length of our large language model. So there is one thing that you want to make sure, which is you don't want to overwhelm the large language model with a long piece of text, because it is going to get confused. And GPT 3.5, as a matter of fact, is not a very powerful GPT model. So I'm sure GPT-4 would probably give me the right answer, even if it would have seen that same memory. But this is a good example that we just saw, so keep it in mind. You have to be careful about that. Now let me upload a PDF file. For example, if I go into data, docs2, and let me upload attention is all you need paper. If you would like to upload a PDF, yes. Okay, so I want to upload a PDF file. Uploaded files are ready. Please ask your question. So I want to ask, explain the attention mechanism in the paper. The attention mechanism in the paper, attention is all you need. So it got the name of the paper correctly, is a key component of the proposed transformer network architecture. So if I view the PDF file, we can see that it is going to open it up for us. So I just refresh the chatbot, and let's ask for a summarization. So I have another PDF file here called stories. It contains 3 different stories for 3 different fictional characters. If I upload the document, and also I selected summarize the document for me. So it automatically passed the document to those GPT models and it's going to give us the answer. So the summary should contain 3 different characters. Amarok is a lone wolf, Fred is a small red fish, and Lily is a young bee. So the summarizer could successfully go through all 3 pages of that document and give us a short summary of that PDF file. If we check these 2 chatbots, we just went through all the branches in RAG-GPT. So now let's go through the WebRAGQuery branch. So as soon as the user here selects WebRAGQuery GPT plus DuckDuckGo search engine plus WebRAG pipeline prep plus web summarizer. So these are all the functionalities that this branch gives us. And whenever we pass a website and we ask our model to prepare a RAG pipeline, the model is going to do it. And then by switching to the second functionality, we can start asking questions about our website. So let's see how it happens in our code. Let me close these modules here and go through the app again. So in our app, it means that our user selected this functionality right here, and we ask a question. So by asking a question, again, we are going to go back into chatbot.py. This is the module that I mentioned is going to distribute the message to the right direction and get the response. So here, we are going to enter this if statement or this if statement, depending on the functionality. So everything with WebRAGQuery initially happens here in this class. So as soon as I initialize this class, which as you can see only get the chat history, the message, and the config of WebRAGQuery, then we just use the function, the method of that class called call, and we get the response. So let's see what happens in this class. In this class, first I have the init function, which initializes all the arguments. Then I have the call function. So in the call function, I tried to provide you with all the necessary comments so you can easily understand what is happening here. First of all, we are going to pass the query to a GPT model. That GPT model, which I'm calling it GPT function caller, is going to get the query and give us an answer. That answer can be either from its own knowledge, or that GPT model might decide that, you know what, I don't have the necessary knowledge, but I have some functions in my disposal which I can return a relevant one based on the query. So let's quickly check the functions. If I come into this module, there is a class called prepare functions. I will not go through all the steps of function preparation for function calling in GPT models. I already have multiple videos talking about this subject, and it is a big subject, so I just want to mention some of the key aspects here. We have access to summarize the web page, retrieve web search result, get instant web answer, web search PDF, web search video, web search news, and finally prepare the requested URL for Q&A. These are the functions that GPT model can return in case it cannot answer the user's query directly, or the user is asking for some of, let's say, these functionalities. So if I ask the model, prepare this specific URL for Q&A, that model would immediately understand that this is the function that my user is looking for. So if the model answers the user based on its own knowledge, we are going to just skip here. This is the line that will be executed. We will just extract the response and pass it to the user interface to show it to the user. But in case the model returns a function, in the output of the model, a key called function call is going to appear. That output is going to also contain the name of the function, the names that we just saw in this function wrap functions right here. So if I have access to the name of the function, I can simply execute that function by doing a matching between the name and the function itself. So this is what I'm doing right here. Prepare functions, execute JSON function. So here, if you look at here, I'm doing a matching between the name of the function that the GPT model returned. I get access to the Python function corresponding to that name. I execute it and I return the result of that function. So the result of that function can be the search results from the DuckDuckGo search engine, can be the search result for a specific PDF, for text, for video, or it can also be the result of preparing a RAG pipeline for that specific website that the user asked for. So in case the function is any of these ones, it is going to be a text. It's going to be a string in the output. So these results here are going to be a string. But in case the user asks for preparation of a RAG pipeline, this result is going to be either true or false, depending on whether the RAG pipeline was successfully created or not. So if I go back here, you can see that I have the function result. And in case the return function was prepare the requested URL, I check if the function result was true. If it was true, I will show the user that the pipeline was created successfully. And now you can start asking questions from the website. And in case the function that the user asked for is summarize the web page, I can directly return the result to the user interface and show it to the user, because the summarization was also happened behind the scene. And beside these two, any other function that was executed is going to return a string, which might contain the search result or whatever else. I'm going to pass that string to another GPT model to get the final answer. So that GPT model is going to see the user's query along with the result from the DuckDuckGo search engine for whatever the user asked for, and it's going to give us the final response. So this is the final response from that GPT model. So again, if there is anything that is a little bit complicated here, there is a whole video dedicated to this chatbot, and I've went into all the details and I explained every step of designing this chatbot. But for now, I want to show you how we can use WebRAGQuery in our chatbot. So I have WebRAGQuery activated on chatbot functionality. Let's first ask a simple question, something like, give me a sample email for inviting my friends to my birthday party. I hope this email finds you well. So this is a typical behavior that we expect from a GPT model. So here the model did not, if you check here the model did not return any specific function. But now let's ask another question. Tell me the recent news about Neuralink. So in case you have followed the news, you know that Neuralink last week made a lot of noise by implanting successfully a chipset into a patient's brain. But let's see what are the most recent news about this company. So this one is Neuralink's brain implant to ultimately help humans merge with AI is sparking debate over safety and ethics. This is for 4 days ago. Let's see the second website. So meet the designer behind Neuralink's surgical robot. Do we have a date here? We have March 29th. So this is 2 days ago. And yeah, so here is the news search that happened behind the scene. Again, the first GPT returned a function which was pointing to DuckDuckGo search engine to search this piece of news. And then we used the retrieved content from that web search and passed it to another GPT model to get this answer that we can see here. Now let me go through one more feature of this WebRAGQuery chatbot. So if I ask, prepare this URL for Q&A, we just saw that there is a function specifically for this task. So as you can see here, by asking that prompt, a function is going to be called, which is prepare the requested URL for Q&A. And then it is going to prepare a RAG pipeline for that website. So if I go back to my chatbot, I can see that, sorry, I could not process the requested URL. Please ask another question. So this can happen due to multiple reasons. The URL that we used probably was not scrapable, so be careful about that one. Let me actually go through Hugging Face main page, main web page. Probably this is going to be a better URL. So if I pass this one, let's see what happens this time. The RAG pipeline was set up for the requested URL. Please change the functionality and start asking questions. So that is one important aspect. It is not going to work with every single website that you pass to it. So it is using a beautiful soap behind the scene to scrape the website and prepare the vector database. So it is going to use LangChain and beautiful soap together. So there are some limitations to what websites you can pass and you can start asking questions versus what websites you can. So this is one aspect that you have to keep in mind. And if I go into this website that we prepared, there is not much actually in it, but let's ask a question. So I would switch to RAG with the requested website. GPT, what is the website about? The website Hugging Face is a platform where the machine learning community collaborates on models, datasets, and applications. So as you can see, it correctly pointed to the right vector database and gave us the result. So I don't see much happening in this website except follow your. So let's ask, who are the AI creators on the web page? Let's see if it can pick up these names. These three names, let me also zoom in. We have these three guys here. Actually, it couldn't. Yeah, so that is a little bit tricky. So just let me ask another question out of curiosity. What is trending on the web page? Let's see if it can pick up some names. It is going to give me these names. So we see Databricks here. We see, for instance, Grok here. So if I go back to the web page, I see the Databricks here and I see Grok here. So actually that was a nice response. It also gave us the number of downloads and the number of stars. I don't know if they are accurate, but feel free to double check. The only thing is, again, this is not an easy website to perform RAG on it, but if you pass a better structured website, you will have better results. Now let's see the final feature of WebRAGQuery, which is, I'm not sure if I can pass this web page to it, but let me test it. Summarize this website. Let's see what will happen. And in the backend, it should call summarize the web page, and it is passing it to our GPT models. Certainly, please provide me with the text you would like me to summarize, and I will be happy to help you. Again, when it comes to website, we have to be careful on what we are passing. Let me pass another website to it. So if I go into here, and if I pass this website, summarize this web page. Let's see if it can summarize a GitHub repository. The LLM0200 repository was correctly summarized. It includes RAG and LLM agents. It provides techniques for training and fine-tuning LLMs. That is correct. It has 87 stars and 54 forks. 87 stars, 54 forks. So that is precise, and that is how you can summarize a website. Let me also pass another website. I'm now curious myself. So I picked up this website, how to develop LSTM models for time series forecasting from Machine Learning Mastery. And let's see what happens if we pass this one. Summarize this website for me. The user is being prompted to enable JavaScript and cookies in there. Okay, so let me also pass this one. So summarize this website for me. Let's see what happens. This is another website from Medium, and let's see. This article discusses the process of designing a long short-term memory. So we just passed 4 different websites to this chatbot. It successfully summarized 2 of them, and it failed to summarize the other 2. So this part of WebRAGQuery can also be improved if you are planning to have a better and, let's say, a more powerful performance on this side. Right now I'm using LangChain, and LangChain is using Beautiful Soap on the backend. Probably if you customize it, you get the text from the website yourself and then pass it to a GPT model. That would improve the performance a bit. All right, so we went through RAG-GPT and WebRAGQuery. Let us again see the configs for these 2, let's say, arms of our chatbot. In RAG-GPT, we saw everything except summarizer config. So this is where I make sure that the length of the smaller summaries, when we sum them up, when we merge them together and we pass them to the final GPT model, is within the context length. So these are the 3 arguments that you have access to, and you can start playing around with them, especially if you are using GPT-4. Definitely you can use a much bigger final token number, and also a better or a higher number for the character overlap. And for WebRAGQuery config, we have the configs for each one of the models and techniques that are being used in that side. So we had the LLM function caller. As you can see, I'm using GPT 3.5 with temperature 0. Feel free to read the system roles and also modify them based on your need. We had the LLM summarizer, again, the GPT model, the temperature. We had LLM RAG, again, the model temperature. We have the config for the RAG side of WebRAGQuery that we just saw when we want to implement a RAG pipeline for a specific website. So I'm using the chunk size of 2000 and chunk overlap of 250, and you can modify these values. This K here right now is not being directly used in the project because I'm using this value right here. So as soon as you start playing around with this value, it is going to change the parameter in the backend as well. So we have MMR search config, fetchk and lambda parameters. So feel free to start playing around in case you want to change those parameters. And finally, we have the summarizer config that we just saw in our chatbot. So we went through RAG-GPT and we went through WebRAGQuery. So the right side of our chatbot is already covered. Now I want to show you how the models from Hugging Face are loaded in our chatbot and how we can interact with them. As I mentioned earlier, the way that I'm using it is by creating Flask web servers. So let's see it in our chatbot. If you go into source utils, you will see a folder called web servers. And if you check this folder, you will see different servers that we are running in the backend of this chatbot. So let me open all of these services and tell you how they are loading our models. So we have LLAVA service, we have a stable diffusion X large, we have RAG reference service, let me put it here, we have speech to text service, and we have load web service config. So we have a web service YAML file here. Here you can change the port number for each one of those models. This is what I put here. You can start adding more configs for each model if you want to change the model's argument from Hugging Face. I didn't do it, but feel free to add any config that you want to the web service config. Then here I'm loading those ports and I'm distributing them over our web services. So let me close this one too. So in LLAVA service, Stable Diffusion and speech to text, the first thing that I'm doing is loading the models. So you can see here, I have a function called load LLAVA, and I'm loading the quantized version of the function. And here is where I'm using bits and bytes config, and that is why I need WSL on Windows or a Linux operating system. Here I'm loading the Stable Diffusion, and here I'm loading the Whisper model. This fourth module is for RAG-GPT, and this is the web service where we can see the PDFs, the source of the results and the responses. So if you have watched RAG-GPT, you're already familiar with this one, but essentially what it does is it prepares a web server for you, and as soon as you have the references, when you click on the PDF files, it is going to host that PDF file for the user to go through it. So let me also close this one. So the way that these three modules work is that I load the models before starting my Flask app. The reason behind it is because you have to be careful about the number of times that you want to load the model, because if you by mistake put the loading side of a model within a part of the code that is going to be called after each query or after each change in the user interface, then you are going to at some point run out of GPU VRAM because your models are going to be loaded over and over again. In the next step, I start my Flask app. I usually have a function. The function is going to expect the user's query along with all the necessary information for inferencing and interacting with that specific model. For instance, in case of LLAVA, it is expecting the prompt of the user, the image URL in case the user passed also an image, and also the max output token. That is what I showed you on the user interface. Then it's going to prepare the prompt in a format that is suitable for LLAVA. It is going to pass the prompt to LLAVA, get the response, and send it back to our user. The same thing for Stable Diffusion. It expects the user prompts, it generates the image, and it's going to send back the image to our user. In case of a Stable Diffusion, I'm actually sending back the directory where I saved the image. So every image that you generate with your chatbot is going to be saved in data and in generated images. So I found it easier, plus I wanted to have the image after I generated them. And with a speech to text, I expect to get the data for the speech, for the voice from the user, convert it to text, and send back the text to our user side. And the other side that sends and receives the data to these web servers is chatbot.py. Again, this is the top module below app.py that does everything for our application. So if you check here, for instance, if I go with LLAVA, it goes through service call.askLLAVA. So let's go to service call. Service call is a class that calls every single one of those models that we just saw with the proper input data, and also receives the response from them. So this is the class that I'm using for interacting with all those services. So if I show you on this image right here, here I have all my models sitting, the Stable Diffusion, the speech to text model, and LLAVA. And here I have chatbot.py and I have service call.py. So on this side, we have these two modules, and on this side, we have all the servers. And then we are creating the connection, we are sending the data, and we are receiving it and send it back to the user interface. So I hope it makes sense for you, but if you just spend a few minutes going through these modules, you will find out that actually it is a very simple process. Now, let me also show you the functionality of some of these models. Again, we saw it in the demo. So if I, for instance, go to generate an image, and if I ask for an image, for instance, generate the image of a supercar and focus on the golden rims. So this is the image that was generated by the model. You can see that the model actually put a lot of focus on the golden side of the car. Let me ask another prompt. Generate the image of a red supercar with focus on golden rims. Interesting. So this is the new image that the model generated for us. Anyhow, this is a red supercar with golden rims, and you can start playing around with the stable diffusion. You can also use more powerful stable diffusion models in case you have access to a more powerful GPU. Let me also go through LLAVA again. So we saw how LLAVA is working with images. Let me go through another image. So images, so I want to show you another image actually. This is the image of a Python function that solves factorial. If we pass, and you can see that the quality is not good. I have to zoom in to find out what is the image. So if I pass that image to my model and ask, what do you see in this image? The image shows a snippet of code written in Python. The code defines a function named factorial. It goes through the function definition, and the code also includes a comment that provides an example usage of factorial function, which calculates factorial of 5. Does it? Actually, yes, I didn't see this initially in the image, and it also came back with the example and also gave the answer. So it also detected the comment at the end. So this model can surprise you over and over again. This is a very powerful and very nice model to have in your chatbot. But just to show you that this model is not just good with images, let's ask model something like, tell me a joke. So if I just send tell me a joke to the model, why did the tomato turn red? Because it saw the salad dressing. So yeah, probably that is not a funny joke, but you can see that the model is very good in interacting with users. And again, this is a 7 billion parameter model. So let's go back to our schema. We saw how the user can interact with this chatbot by uploading a document, uploading an image, sending a text, sending a voice, and start using these features and these functionalities of our chatbot. We also saw again how these two frameworks work within the body of our chatbot. Now let me just give you some final suggestions and keynotes. So my first suggestion would be definitely to test bigger LLAVA models. This is just fantastic. I have a lot of applications in mind with this model. Probably you also have a lot of ideas in mind. So that would be suggestion number one. The second suggestion would be to add text-to-speech model. The reason that I didn't add it in this version of the chatbot was actually, if you check the Explore folder, you will see that I explored some of the open source text-to-speech models, but the best one that I found was actually the OpenAI text-to-speech model itself, but I didn't want to add a closed source model with which we have to interact using API calls. So the reason behind the fact that those open source models were not good enough were two things. First, they were adding a lot of delay to the system. And second, the input and output length of those models were not just good enough for our chatbot, since our chatbot can sometimes come out with long pieces of texts, and I had to chunk the outputs and send out the chunks to the model and start augmenting them together, which I didn't go with that. I will keep it for the next versions, and as soon as I find a good text-to-speech model, I will add it to the chatbot and release it. The third suggestion would be to improve actually not just RAG, but all the arms and functionalities that we just saw together. The final keynotes would be, first of all, I didn't cover the installation of WSL2 because I found out that there are very good videos and tutorials on how to install it. And as a matter of fact, if you check it, it is probably a 5-minute read before you understand how to install it quickly. The only thing is I personally had to fix a config file into my WSL to establish the internet connection. I will include a link into the description, so in case you have the same problem, you don't need to go through it and figure it out by yourself. Finally, the multimodal chatbot will be upgraded. So this was version 1 of this chatbot. So that would be the final keynote. So once again, thank you very much for watching the video, and I hope to see you in the next one.